Alrighty, here's 6-1, day 2. Continue our theme in the first section of angles. Okay. There'll be a couple things in here that are new, mostly at the end. Okay, on the last slide. Most of it won't though, because really all our focus is going to be today is seeing some similar concepts to we saw on the first day. Okay, there'll be some similarities, but looking at them through a different angle measurement known as radians. Okay, that's the big thing to understand before we look at them is because they're just not as intuitive as degrees, right? Just when you say like an angle is 60 degrees, you probably get an image of it in your head of what that is pretty quick. Okay. Radians aren't always like that. If I was like, hey, here's an angle that's 2 radians, you know, what? How I don't have a mental picture as to how big that angle is. But it's basically another unit to measure an angle. In terms of like the stuff we can do in trigonometry, at times radians can be really helpful from the math side. They work better with getting exact answers. They work better with certain formulas. So you'll see that we'll use both, okay? So let's think about it this way, okay? The circumference of a circle, which you've probably seen before, 2 pi r, okay? Now, if we were to say the radius was 1, it might be kind of weird why that's the case, but let's say that it is, all right? We'd have this situation where if we wanted to talk about a radian, when r is 1, s is 1, that would imply that our angle theta, right, that I think that came up in the first day, that's just a common variable name for an arbitrary or unknown angle, that is 1 radian, okay? Now, they don't have to be like both 1. I'm gonna use that down here to kind of talk about how many radians there are in a circle. But really, if you have 1 radian, you're talking about this scenario where your radius right here, the radius of the circle, S is the arc that is formed by the angle, right? Technically, that angle is formed by 2 radii, plural for radius, okay? So if that is formed so that the length of the radius is the same length as the arc, you have a radian, okay? If you kept going and you formed it so that the arc was twice as long as the radius, you'd have 2 radians, okay? So now if you did make R1, okay, that's this kind of scenario I was talking about here, where if, you know, notice they're the same size, right? Because if you want just a straight definition for a radian, it is the angle is the length of the arc divided by the length of the radius. Okay, that ratio tells you the angle in radians. If r was 1, the circumference would be 2 pi. Okay, now 2 pi is like roughly 6.28. Okay, so this gives us I'm gonna kind of add to some of the common conversions that we should really know. Okay, on the next slide I'll give you a few more, but 2 pi radians, which is again a little over 6, is the same as 360 degrees. So if you were talking about like 1 revolution around a circle, you would have 2 pi radians. Okay. All right, so right here we'd have 0, okay? Now to divide this into fourths, here's what we'd have. Right up here at 90 degrees, we'd be at pi over 2. This would be pi, and then this would be 3 pi over 2, okay? It's kind of the basics of radians. Again, they're a little different. but understand they're another measurement for an angle. That's all. You can think of it like units. When we're measuring an angle, we could go two different routes. Do you want to measure the angle in degrees? Sometimes we will. Or do you want to measure it in radians? Sometimes we go that route. It just depends. Okay? Kind of as a random side note up here, that this doesn't come up with like any conversions, but it's kind of like just a good FYI type thing. If you have one radian, okay, this isn't exact, so just know it's kind of an approximation. A radian is like roughly 57 degrees, okay? Right around 57, all right? So again, they're kind of different, whereas if you have an angle that's like 2.5 radians, you could be talking about a very large angle that's well over 90 degrees, okay? Conversions aren't too bad, okay? If you want to go from degrees to radians, because this is a really common thing, having these two measurements, is we kind of put ourselves in position where we'll be able to, whenever we want, in any situation we want, be able to convert back and forth between the two. Now, if you kind of followed this part up here, right, if 2 pi radians is 360 degrees, just divide both sides by 2. And you can already see this number show up on the diagram, then pi radians is 180 degrees, okay? So down here we'll do a couple of these. I got 20 degrees. Multiply that by pi over 180. Very often when you're switching two radians, you end up with a pi in your answer. That's really because it's, the number of radians in a circle is really based off the number pi, because it's kind of all about the radius and their circumference, and, pi just kind of shows up. We do expect that we'll reduce the fraction as much as possible. 20 and 180 both have a common factor of 20. So you get pi over 9, okay? Negative 250, negative angle doesn't matter, right? If we want to get to radians, we have to multiply by the ratio of pi over 180. Okay. Biggest factor that goes into both of those is 10, so we'd have negative 25 pi over 18. Okay. I'll just switch gears over here and do the opposite. 3 pi over 4, we'll multiply that by 180 over pi. This will happen a lot when you're going 2 degrees, but not always. The pi's cancel. And then you would have 3 times 180 over 4, right? At this point, in terms of units, I'd really only need to have it on my final answer. Honestly, I don't care if you have the units while you're writing out the work. But we're going 2 degrees, which means, right, degrees have that little symbol of a circle to the upper right. That would have to be there, all right? Because it can get a little tricky if we're not careful. Radians don't have, they're a unit, right? They're a unit to measure angles, but they don't have a symbol. So if you know in a problem you're talking about an angle and it doesn't have any units, specifically it doesn't have the degree symbol, it's assumed that you're talking about radians. Okay, so on these answers I got to be particular when I simplify this and I say, oh, it's 135 degrees. Got to make sure that symbol's on there. We're talking degrees, not radians. Now, if you get something like this, negative 3.14159, okay? We're going to degrees, so we're like, all right, 180 over pi. But you notice there's no pi to cancel out. This is the one case you would go for an approximation, right? So you would just throw it into your calculator. You would get negative 179.99, right? Now we're basically talking about negative pi. So we could roughly call that negative 180 degrees. Okay, but if you get, starting with an angle in radians that's a decimal like that, you're probably going to be doing an approximation, okay? But if it's like part C and you see you've got the pi's in it and the pi's cancel, then we should be looking at an exact answer. Okay, so just to kind of recap, because we've seen this stuff in day one when we were talking degrees. Coterminals and whatnot. Before I get to those, let's just throw these on here, right? Just really, really good conversions between the two to just know off the top of your head. If you forgot them, you could use the rules on the other slide. And they're not new, right? I mentioned them on the previous slide. That's where we all started, right? The 2 pi radians is one circle, 360 degrees. Divide that by 2. This is another really important one to know. That pi radians and 180 degrees are the same measure. Okay, they're measuring the same angle. Divide by 2 again. This one we haven't, like we saw it on the diagram on that first slide, but I didn't really talk through it much. Pi over 2 is the same thing as 90 degrees. All right, so if we're talking coterminal, right? 2 angles that have the exact same terminal and initial side. The other day we had said in degrees, add or subtract 360 as much as you want, all right? So if we're talking radians, add or subtract 2 pi. If we're talking complementary angles, right? Need to add up to 90 degrees. So you could, if you wanted to get a complement, we saw that you would subtract it from 90, okay? Same thing here. It's just you have to subtract it from pi over 2. That's the same angle if we're talking about radians. Supplementary, you would have subtracted it from 180. If we're talking radians, it's from pi. Okay? Coterminal, complementary, supplementary, not new, right? You just, if you're dealing with radians, you're dealing with different numbers. But the ideas are the same. All right, for each of these, we'll sketch it, find a couple coterminals. And then find the complement and supplement. I'm just going to start for all 3 of these to get a little grid here. All right. Pi over 5, right? So now it can be a little bit trickier because radians are going to have you working with pi and with fractions. Okay, but pi over 5 is going to be in quadrant number 1. Okay, in quadrant number 1. A couple different routes that you could go if you needed to check. Worst case, if you had to convert it over degrees, just because then it's kind of like a number to a number comparison, that's fine. Sometimes it's easy to tell with the fractions, sometimes it's not. You could get common denominators that I think you'd see here that, yeah, pi over 5, right, is going to be less than pi over 2. Okay, you can kind of see it and figure out it's in quadrant 1. All right, so for coterminals, right, we talked about that on the previous slide. Pi over 5. I can add 2 pi, but this is where operations with radians can get a little bit more tedious, okay? Now you're probably seeing that thinking, hey, wait a minute, aren't you supposed to add 2 pi? And if you look closely at this number, I did, right? You'll find yourself doing this all the time, that whatever number that you're working with, if you're doing operations with an angle in radians, you're gonna have to switch the denominator all the time. I need to add 2 pi to get a coterminal, right? In this case, it would be like going all the way around and then getting back to the same spot. But I need it to be in terms of the denominator of 5. If I subtract it, I should get a negative. And I do, okay? Complementary and supplementary, okay? Same thing happens here. It's like, all right, I need to take, in terms of what the other, I'm doing supplementary first. In terms of what the other slide said, though, pi minus pi over 5, right? Looks good. Well, wait a minute. I don't have a common denominator, so pi, right? I need to write that as 5 pi over 5, right? Same number. I had to multiply the top and the bottom. If you thought about it as a fraction, right, it's pi over 1. I had to multiply the top and the bottom by 5. I get 4 pi over 5, okay? Here would be complementary, right? We get into the same thing, but we're not guaranteed that, like, all the time, you know, it's going to work out that, like, oh, if the angle's over 5, then the common denominator is going to be 5, right? Actually, on this one, we end up with a common denominator of 10. Don't get freaked out by that. It's fractions, right? It's no different than adding or subtracting. Fractions, we need a common denominator. Don't think that it's any different because we have the pi in there, okay? That is what it is, not a big deal. The pi just goes along step by step, okay? It's kind of like it's, you know, it's just sitting out there on the top just doing whatever, okay? So it doesn't change the math behind how you're working with that fraction. Okay, so here, negative pi over 7, okay? So it can be a little bit, let me go through kind of the references for each of the angles here. We had pi over 2, pi, and 3 pi over 2. Negative 4 pi over 7, right? I'm going the opposite route here would be over here, right? And so I'm going the opposite, so I'm thinking of this 3 pi over 2 as negative pi over 2, right? But I could tell, you know, 4 over 7, I'm not going to make it all the way to pi, right? So the question is, do I get past negative pi over 2, okay? Well, there, if I were to get, you know, negative pi over 2, this is where you just kind of got to take your time and figure out what's going on with your angle in radians. That would be negative 4 pi over 8, right? And I'm negative 4 pi over 7. Okay? Which, as a number, is a little bit bigger, right? Just slightly bigger than negative 4 pi over 8, okay? All right, and same deal here. Here's negative 4 pi over 7. So this part we're doing the coterminals, right? So I'm adding 2 pi, just like always when we're talking radians, but notice right away, I'm like, all right, if I'm adding 2 pi for this particular angle, I need to write that as 14 pi over 7. And then down here, negative 4 pi minus 14 pi over 7 would be negative 18 pi over 7. Okay, I would normally check, normally, we're just not seeing it happen. I would check those fractions to make sure that they could be, like, that I would reduce them if possible. Okay, just kind of like when I was doing the conversions on the other slides, we should always check to reduce them. I just haven't seen one where you can, right? They've all been in lowest terms. Down here in part C, we're going to say none and none. This can get a little complicated. Some mathematicians would tell you that for complementary and supplementary, it's any two angles that add up to 90 and 180. We don't take that approach, right? If we're looking at the whole complement supplement thing, we have two positive angles. Okay, so if you ever see that you're asked about it for an angle that's negative, we just say none. We're not getting into that whole discussion. Okay. All right, last one. Here's pi over 2. Okay. All right, so 15 pi over 11, right? Past pi over 2, right? Past pi, it's bigger than pi. Question becomes, is it bigger than 3 pi over 2? Okay. Again, you could switch to a common denominator. You could, one other thing you could do is throw them to a calculator and just compare them as decimals to kind of see exactly where you're at. You'll see it's not, okay? So I'd be down in quadrant 3, right? I can't quite make it to 3 pi over 2, so I'm right there, okay? Same deal here. Right, I'm going to add 2 pi, but of course I'm going to write that as 22 pi over 11. Getting my first coterminal, which would be 37 pi over 11. Can't reduce that. Subtract it as well. Okay, 15 minus 22, we get negative 7. Again, this one's not negative, but it is bigger than 180 degrees. So for the complement and supplement thing, right? Again, we would say none and none. Here we can really, right? We could offer reasons for both of these, right? Because here I was just going to say because negative 4 pi over 7 is less than 0, right? It's a negative angle, so we're not going there. This one happens to be positive, right? But if we're talking supplement, 15 pi over 11 in terms of radians is over pi. And then obviously down here for the complement, 15 pi over 11. If it's bigger than pi, it's bigger than pi over 2. So again, too big, none. All right, last two things. This is the part at the beginning that I was saying was kind of new. Okay, these arc length and sector area. Okay. For labels here, let's just say, just so you know that if you have R, you're talking radius. This applies to all four formulas. Theta is the angle. Okay, just to kind of define your variables. So just to kind of mark what you're getting, right? For arc length, right, you see the angle theta determines how long this part of the circumference of the circle is. That's what those two formulas will find you if you're given the radius and the angle, okay? If you're given the radius and the angle, right? The formulas kind of look different, right? This is what I was saying at the beginning, that if you're working in radians, a lot of times they actually kind of are more conducive to formulas and end up with slightly easier ones, okay? Now I want to show you here, the radian one looks really different, but it actually has the same setup. If you started with the degrees, right? All you'd have to do is change the 360 to 2 pi. But I want to show you just real quick what happens. because that's really the jump to radians, right? We've seen earlier that 360 degrees, 2 pi radians, right? Same, it's one complete circle. Notice what happens with 2 pi's. All that's left over is theta times the radius. Same thing over here, right? If you're getting the area, right? Same thing. You've got an angle and this chunk of the circle, but it's not the length of the arc. We want the area, like the two-dimensional space that the sector takes up. Same thing, you would have theta, right? Pi r squared. I'm looking at the degrees one, and if I wanted to switch over to radians, again, that 360 just becomes 2 pi, but once again, you see this canceling of the pi's, and you get theta r squared over 2, okay? Which is why those pi's just cancel out and they're not there. All right. So we'll start with the first example right here. Arc length, right? Got a 140 degree angle. 2 times pi times 6 over 360, right? And these are pretty straightforward. They just get tossed into your calculator. You'll get a decimal approximation for these kind of problems typically. That's what you should expect. And the arc length is about 14.66. It also wants the sector area, right? Notice on these I identified right away that the angle measurement is in degrees, so I'm not paying any attention to the radian formulas. Can't use those. Got to use the degrees. So for area, 140 pi times 6 squared over 360. Again, that's a calculator piece. Just throw it in. Should get 43.98. Remember, units on this one, it's area, right? So squared units, okay? Because again, one is measuring area, one is measuring length. So you see that show up with the units. All right, if the arc length is 18 inches, right? So right away I'm ignoring like these formulas up here, right? Both of these. I'm ignoring because those measure area, and it looks like this problem is about arc length. (18 inches, radius is 4, what's theta? Okay. Specifically, it wants it in radians, right? So that tells me formula-wise. I'm in radians and looking at arc length, so I want that one. Told me that S was 18. Told me that R was 4. And divide both sides by 4, right? This does involve a little solving. I divide it by 4, and I can see that the angle that it's talking about is 4.5 radians. Okay. So even though most of the lesson was about radians, notice with these new formulas, degrees made a little comeback and worked their way in there today. So, all right, that is all for 6-1, day 2.